An empirical formula is a simple ratio between two chemicals. If we can figure out how many moles there are of each one of these substances in a lab, then we can divide by the mole ratio to see how many of silvers there are to how many oxygens. To do this in a lab setting is really kind of a clever thing to do. You'll heat it up, and what you can do is you can separate them into their elements. So you can remove the silver from the oxygen gas. So this O will turn into O2 gas and go away. And if you keep track of the mass that goes away, you know how many grams of oxygen you had in the original sample, and then you know how much silver you had in the original sample as well by the solid that stays behind. Okay? So we can separate those just with a little bit of heat, drive off all of the gas, and refine our silver. And then the mass difference tells you how much of each thing you have. We're going to do the same thing with another type of chemical called a hydrate. And it's like an empirical formula. We're going to get a mole ratio of two different elements. And if you've ever seen those little like silica gel packs that come in food or clothing or packaging, what they're meant to do is they're meant to absorb water to keep moisture away from your items. Because those chemicals can absorb water, they form a structure around them with a certain fixed number of molecules that are called hydrates. And what we're going to try to do is we're going to try to find the ratio, just like an empirical formula, the ratio of the water to the molecule. There's going to be, for every one molecule, how many waters surround it, so 1 to X. And we're going to do it in the same way. We're going to use a little bit of heat to separate the chemical, whatever the chemical is, from the water. And if we drive off all the water as gas, the mass that remains is our solid, dry chemical. So we call this one a hydrate, and the dry version we say is anhydrous. And then from that, if we know how many grams of this went away, how many grams of this remain, we can get a mole ratio from these two things as well, convert them into moles to see how many molecules are on the hydrate, how many molecules of water. So that's what we're going to be doing in our hydrate lab.